So this would have shown up on the no calculator part of your test, which I suppose I could still do at home. We'll find out. But, so step one is always sketch just the general shape. And it's literally going off the leading coefficients and what the degree is off of that function. When I talk about finding the zeros and using the rational zeros test, what you're doing is you are taking all of the factors of the leading coefficient and you're going to divide it by all of the factors of the constant. Okay. And what I'm going to do is I'm just going to put a generic plus or minus at the front. Because what this does is it gives you a narrowed down list of what kind of things you need to check to see if you can divide stuff out. All right. Ready for step 3? So step 3 is finding the y-intercept, and that is literally just your constant. All of this stuff. Calculus. Calculus is used in physics and biomedical engineering, like, not necessarily the by hand part. The by hand is really me checking to see, do you know synthetic division? Do you know the possible rational zeros test? Can you factor? Blah, 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 blah. It's me being a stinker and making sure, like, I'm checking multiple things at the same time. I know, right? No, you can tape them into your notes when we're ready. I have, like, double stick tape. It makes life easier. All right, ready? Okay, so you've got your first example right here. And I just noticed a minor mistake. I flip-flopped up here. Yeah. Crap happens. It's not leading coefficient over the constant. It's constant over the leading coefficient. So if y'all need erasers, let me know. My bad. It's Monday. Yeah. Yeah, no, not at all. All right. You got that fixed? Okay. I was going to say, it definitely helps out having it the right way when we go and do it on the first one. Otherwise, we're going to have all fractions. All right, so step 1 off of this first example is to do what? Sketch the general shape. So, leading coefficient's positive, yes, and it's degree 4. So what's it going to look like? Yeah, it's going to look like a W. That's literally all I need for a sketch. Okay? It just makes sure when you go to graph it, it's the right kind of shape. All right, now step 2 is where we go through and we're trying to do that. What are my zeros going to be? Because let's be honest, you can't factor this right now, can you? It's 5 terms. I got nothing. So, I've got factors of 12 over factors of 1. The factors of 1 part's easy, right? Because it's 1. It is 1. So, I got a plus or minus. What are all of the factors of 12? 1 and 12. 2, 6, 3, 4. So, if you notice, when I write this, well, I just really wanted to move you closer, but you're not doing it. I go end to end and work my way in, just because that way I'm not missing any of my numbers. And I'm a little neurotic, and I enjoy having it numerically ordered. All right? So that's it for step 2. You're just making a list. Now, step 3 is to go through and figure out which of these actually works. Okay? This is the guess and check part. This is the part that kids hate, because it's a lot of synthetic division. But this is why I showed you synthetic division, because let's be honest, having to do this long division style would suck. Alright, so, when we go through and do this, we're literally checking these 12 options. Because remember, there's a positive and a negative. Right? So, I'm going to start by taking positive 1 as my 0. So I've got 1, negative 3, negative 9, 23, and negative 12. Yeah, for synthetic division. Ready? So we got lots of checks. Actually, I'm going to do this. Or don't move down. That's cool too. I was just going to do this. So we have some more room to double check. Alright, so ready? Drop down my 1, negative 1, negative 4, positive 4, negative 5, positive 5, 28, negative 28. Is my remainder here 0? No. Well, so here's the thing. If it's not 0, I don't care. Okay? This is why you make the list of your possible rational zeros, because this tells me that x plus 1 is not divisible into that polynomial. Okay? So this one's out of the running. And again, which one do you want to check this time? Negative which one? Negative 3? 1, negative 3, negative 9, 23, negative 12. We're going to divide it out. Yep. So, no. Hang on. You guys start doing that division. I need more space. All right, did it work or no? It did? Okay, so what this tells me is that x plus 3 goes into my lovely little polynomial. Now, here's what we're going to do from here. I am not going to continue to do long division with that giant polynomial. Okay? We're going to use this smaller one. Because remember, the smaller one says x cubed minus 6x squared plus 9x minus 4. Can I factor that now? Not with grouping. Not quite there yet. All right. But it's always good to check right here, because it could be you could factor it by grouping from here. What do we want to check next? Guys, we had that whole list. Pick a number. Positive 4. Now, when we go to do this, use the numbers that you got right here. Because that's 4 checks instead of 5. And if you think about it, if it's divisible by the whole polynomial, it's going to be divisible by a smaller part of the polynomial as well, right? So 1, negative 6, 9, negative 4. Did it work? Yes. Sweet. So, oh, you jerk face. This is now x squared minus 2x plus 1. Can I factor that? Yeah, what would it factor to? I heard it. What was it? Yep, x minus 1 squared. So far, we have factored our original polynomial to be x minus 4, and that came from this one right here, x plus 3, and that came from the one up top, right? And then I've got x minus 1 squared. Okay? So far, so good? That's what that whole thing factors into. Now, I always recommend to kids do a check right here, because what was the degree of our original polynomial? 4. Right? So I should have 4 x's. 1, 2, 3, 4. All right? It just helps kids to make sure they didn't lose a 0 somewhere along the way. Now, it says watch for multiplicities. Right? And when we talk multiplicities, this one's even, so it's going to be a touch. And then these, because they technically have a 1 here, these are both crosses. No, although that would be a really funny, like, it's on your teacher test, like, can you make the fancy dancy squiggly brackets? Alright, what's my next step? X and Y table. Okay, so you have to keep these zeros. I'm going to move this bad boy over here. I know my screen's a big fat mess, but I'm trying to make sure we can do it where we can still see it. So remember, I've got zeros at positive 4, negative 3, and then I've got positive 1 somewhere in this mix. Yes? Now I also know 0, which is my y-intercept. So what was the constant on this original problem? Negative 12. That's a 0, that's a 0, that's a 0. So now I got some other things I got to plug in and check. I'm going to want to check probably like -2. Let's do a +2. We could do a -1, and we could do 3. Now that gives us 4 numbers to plug in and see what it equals. Okay? So remember, we did all of this stuff with synthetic substitution, am I right? So, with synthetic substitution, give me this line, please. When it comes to synthetic substitution, as you guys are going through, you're plugging in exactly what you see right here. And you're plugging it back into the original polynomial. Alright? That is one method of doing this. Plug it in, see what you get. You want to see it easy way? Look at your factored form. Okay, factored form is x minus 4, x plus 3, x minus 1, quantity squared. You can plug in to the factored form for the exact same polynomial. So, if I go to plug in -2, I've got -2 minus 4, -2 plus 3, -2 minus 1, quantity squared. So far, so good. So, what is -2 times -4? Or minus -4, I'm sorry. Yep, -6. Bless you. What is -2 plus 3? And then what's -2 minus 1? And I've got -3 squared. So I've really got to do -6 times 9. What's -6 times 9? Alright. So, you guys, right here, I want you to plug in -1. You guys are going to plug in +2. You guys are going to plug in +3. Alright, that way you don't have to do all 3 of them, and we can move on. You guys are doing -1. I was going to say, I can't tell if you guys are conferring or if you're plotting. Oh, God. Alright, what do you guys get for -1? Negative what? 40. What did you guys get for 2? -10. And what did you guys get for 3? -24. And I got a 0. Three. Yep, it should be -24. Alright, so what do you notice about a lot of the points that we got? They're not on the graph. So can we change the axes marks, at least for y? No. No, those are actual points. Alright, so for y, could we instead go by, I don't know, 5z's? Because that'll get me to 50 right here. We do have 54. But that would be barely off the graph. We'll just go with it. I like 5s or 10s, just personally. So we're going to tell this graph y's equal count by 5s. All right. We are not going to change that x value, though. All right. Bless you. Huh? Yeah, it's kind of, it looks like you just kind of zoomed out this way. You just kind of crushed it down a little bit. Yeah, we're going to use that. So I've got -3 right here. I've got -2, which is down here at 54, so there-ish. -1 is at -40. 25. 40 is right here. 0, -12. +1, 0. 2, -10. 3, -24. 4, 0. All right, so remember our original shape should look like a W, which means I have to start from this direction. Come down, cross, up. Now remember, we said -1 was a touch, or a +1 was a touch, yes? So you're just going to boop the x-axis, come back down, go back up again. Oh, crap. You're right. Oh, dude. I skipped that one. Decided I didn't like it. Bueno? As bad as we were thinking, not as bad as we were thinking. Because you really only have 4 of these to do for the homework, because I know it's really work intensive, but it's a lot more guess and check. And there's a lot of time to like double check and see if you can factor, because if you can factor right away, that's kind of your goal. No. No, you're going to have to look at the calendar for it, too. Yeah. All right. So, ready for this one? What's up? Oh, yeah. I just was going to wait until after so you guys knew where to stick the other one. I do have scissors. Yeah, with double stick tape, you just put like tape in the middle of the graph and the back and just mush it down. All right, so for this one, step 1. What's my general shape going to be? Up, down, up. So kind of like this. All right, so, Michael, hang on. It's going to be like that. Now, step 2 says to go through and find all of your rational zeros, except it starts with the leading coefficient and the constant. Is there a constant on this one? No. No. So, let me talk. I can factor this immediately. I can pull an x out of it. And then I can factor the rest of that quadratic. So this is why you want to check it before you jump right into the rational zeros test, because sometimes you can avoid that. And let's be honest, I'm not lazy, I'm efficient, I want to hurry up and get my homework done. So, yeah, you could just say I'm lazy too, because lazy people get their crap done faster anyway. So it's x, Michael, x plus 4, x minus 3. Middle term is positive. Bless you. Bigger term needs to be positive. So remember, at the beginning, I pulled out an x from... Guys, shh, you can't stop talking over me because I'm recording this, remember? You don't need to answer. I'm the one with 2 master's degrees. All right, so Emma, remember, I can pull an x out of those first 3 terms. Okay, so that's why it's 1 over here. Because this is actually at the origin. This one. So I need factors of 12 that are going to add up to give me 1. Only way to do that is 4 and 3. Okay. So I can jump right into my table, right? This one's nice because I don't have to do quite as much work. So I've got negative 4, I've got a 0, and I've got a positive 3. So I got some numbers to check. Do we want to check all of them, or do we just want to kind of split the difference and, like, maybe just check negative 2 right here? Yes? Do we want to just check 1 in the middle, kind of call it a day? And then maybe just check 1 here? Now, do you guys like plugging those next 2 into whatever you've got factored? Okay. So this half of the room, you guys want to check negative 2? You guys want to check positive 1? Did we get it? We're conferring. Talk to each other. What'd you guys get? You made sure you plugged it in all 3 spots? That's a negative 10. Yeah. So it's 20. You guys got negative 10? All right. So, what do we want to make our y-axes on this one? Just like twosies? Because that'll get us up to positive 20. So I've got negative 2, positive 20, that's right here. Negative 4, 0, origin, 1, negative 10, and 3, 0. Something like that. weird. Ta-da! That's it for notes.